All right, honors pre-calc. On this video, continuing graphing, we're really going to do a review where we're going to graph quadratics, and we know how to graph quadratics, and we're going to get a parabola, but it's going to be a different form than we saw it in earlier in the year. Um, it's going to be in this standard form right here, where we have ax squared plus bx plus c, but I want to get it in this vertex form, all right, which is this right here. Okay, where A is going to basically tell us if the parabola opens up or down, if it gets wider or skinnier. The H and the K, that's going to be the horizontal and the vertical shifts of the vertex. So I'll even put here the vertex is HK. All right, this is the form that we saw it in, this vertex form. Um, in order to get it in this vertex form, or here it's in standard form, this is where we have to use completing the square. All right. Now, hopefully you did see this last year. You should have seen it, so this should be review. So completing this square is going to basically allow us to get a binomial that is squared right here. And in order to do that, well, you can only complete this square if you have the leading coefficient for the x squared is 1. Now, if you look, the leading coefficient for this is not 1. I'll even zoom in here. Oops. And there we go. All right. So in order to get this leading coefficient for this quadratic to be 1, we're going to pull out a 3 because that's the leading coefficient. And then on the inside, we're going to get x squared plus 4x. Now this constant, I always have this kind of hanging on the outside here. All right. Okay. And then what I'm going to do is I'm going to have a box on the inside and then a box on the outside to kind of compensate. All right. Now, in order to complete this square, we always take half of this middle coefficient and then square it. So we would take half of 4 or divide it by 2 and then square it. So half of 4 is 2 and 2 squared is 4. All right. Now, if we distributed 3 to everything and I distributed 3 to this 4, it's really like I'm just adding 12 to this equation. Well, if I just add 12 to it, I'm completely changing the original equation. So to compensate, this box on the outside right here, I have to do the opposite of this. So this is going to be minus 12. All right. So really, eventually, if you distributed everything, this 12 and the negative 12 would cancel, and we would end up with what we started with. All right. So then this is really what we have. This 3 and then the x squared plus 4x. Oh, I forgot to put a plus right there. Plus 4. And then the outside, when we combine this, 11 minus 12, we get minus 1. Now this, after completing the square, we're going to get a binomial that's squared. So this quadratic in vertex form, this is going to factor to x plus 2 quantity squared and then minus 1. All right. Now, these two quadratic equations look completely different, but if you were actually to FOIL this out and combine all your like terms, it's going to be this, what we started with. They're actually the same. But this is a lot easier to graph. So if I were to graph this, the vertex would be at -2, -1. I'm just going to put a real quick sketch. Like I know you guys know how to graph this because we did this earlier in the year. So -2, -1 would be here. Now, since this a value is 3, it's almost kind of like the slope. If I were to go to the right of the vertex 3 units, so 1, 2, I'd be at x equals 1. If actually, if I were to go to the right 1, I would go up 3. That's how it would work. So if I were to go to the right 1 and x equals -1, I'm going to go up 3. 1, 2, 3, and I would get this point. Then if I were to go to the left one, then I would go up 3. 1, 2, 3. So that would be what those points, -1, 2, and -3, 2. And that's the graph. All right. So we want to get it in that form the vertex form by completing the square. All right, let's do one more. All right, now number two, if you look at it, they try to trick you because they switch. They don't have the leading coefficient written first. Leading coefficient's -3. So let's just switch this around. So I have in that standard form. So this is -3x squared plus 6x minus 5. All right. So in order to complete the square to get in that vertex form, this leading coefficient for x squared has to be 1. So I'm going to pull out a -3. When I pull out the -3, then I'm going to have x squared. Now, since I pulled out a negative, this positive 6x, that's going to be a negative, and it'll be -2x, right? Because -3 times -2x will give me positive 6x. And then this constant, you always kind of leave that hanging outside, right? And then to complete the square, it's going to be a plus. And then to compensate, I'm going to put a box on the outside. Now, again, if I complete the square, I take half of this coefficient. So I take half of 2, and then I square it. So half of -2 is -1. -1 squared is +1. All right. Now, I'll put a common mistake. What a lot of students will do is they'll put -1, but this number is going to be opposite of what you get when you distribute with this. All right, so I'm going to erase that, what I just put in there. All right, this is not going to be 1. Okay, so when I distribute -3 to this 1, I get -3. And then on the outside, to compensate, I'm going to do the opposite of this. So I'm going to put +3. All right, so then we're almost there. So then I have -3 times the quantity of x squared minus 2x, oops, forgot the 2, minus 2x plus 1. And then on the outside, the 5 plus 3 is going to give us, actually, you know what? This is a -5. See how easy it is to get mixed up? This is a -5. So then that -5 plus 3 on the outside is -2. And then we can factor, and it's going to be a perfect square. This x squared minus 2x plus 1 will factor to x minus 1 quantity squared, and then -2. And this is that same equation, but it's in vertex form. And if I were to graph this, the vertex would be at 1, -2. The a value is -3, so this parabola is going to go down. So real quick, if I want to do a rough sketch, okay, I go to 1, -2. That's the vertex. And then since a is -3, when I go to the left, I'm going to go down 1, 2, 3 units. So that's going to be at 0, -5. And if I go to the right one, same thing. I go down 3 units. All right, and then this is the parabola. All right, so what this really was testing you on is the whole process of completing the square. You guys are good with graphing the quadratics, but hopefully this just gave you a refresher of how to complete the square, to put it in vertex form.